Alright, so now we're getting into the fun stuff. Graphing trig graphs. So the parent curve for each function is represented once around the unit circle 0 to 360 or 0 to 2 pi radians, depending on whether you're looking at degrees or radians. But again, what they do is they take that unit circle that we were talking about, so this bad boy, and they cut it up into looking into the graph of it. So these are what we call periodic functions. So they are endless repetitions of the same graph. Now generally, we only look at a section of them, but they do continue on forever and ever. So with our trig graphs, the x-axis represents the angles, and those are going to be in radians. And then the y-axis represents the values of sine, cosine, or tangent of that angle. So whatever angle you're dealing with, whether you're looking at the sine, cosine, or tangent curve, that's what the y is representing, is the value you would get if you took sine of 90 or sine of 35, whatever angle. So with our trig graphs, we have what we call key values. You'll hear me refer to these also as key points. These graphs are always very repetitive. They follow the same exact pattern, so they always have these key points that you must hit. So these key points are 0, pi over 2, pi, 3 pi over 2, and 2 pi, which all of those are the quadrantals. So that's our 0, 90, 180, 270, 360. Those are our key values that we look at. Some optional ones that you could use if you needed to would be your 45s, so again, you can use those to get you some more information if you needed it to, but the main ones we need to focus on are these ones up here in number 3. Those are our key values that we want to use. So again, this is my unit circle, and yes, I really am not very good at drawing circles, but I try. So here are the quadrantal points. And again, those are the ones we use. Those are our key values. And remember, cosine is the x portion of your points. So 1, 0, -1, and 1, those values there. So we are going to first make the cosine curve. So I'm going to put my scale here. Again, pi over 2 pi, 3 pi over 2, and 2 pi. Those are our key points that we deal with. This, of course, right here at your origin, that represents 0. And so, excuse me, I'm going to label my y-axis. I'm going to do every other one as 1. So if I look at my 0, my cosine value of 0 on my unit circle is a 1. I'm going to put a dot there at 1. 90, my cosine value is 0. 180, my cosine value is -1. 270, my cosine value is back at 0. And then 360 comes back up to 1. And that right there is our cosine curve. So our cosine curve always follows this pattern. It starts high, then it goes to 0, and then it goes low, 0, and then high. So it's high, 0, low, 0, high. It always follows that pattern. And I say high and low because, as you'll see as we go on, those values can actually change as to what your high is and what your low is. So as long as we remember it's high, 0, low, 0, high. That is our pattern. So if I could somehow take this part of my graph and kind of flip it, and then take this section here and flip that, there is our unit circle again. So as I was saying, they just take the unit circle and they cut it open so that it ends up making this curve here. So then we have our cosine curve. So other thing, this part of the curve here, these are all the cosine values from quadrant 1, your 0 to 90. Let's get a different color. Here to here, and then I'll use green. So these represent your quadrant 2 values, 90 to 180. These are your quadrant 3 values from 180 to 270. And then, that's right, those are your quadrant 4 values from 270 to 360. So again, it's all still connected to the unit circle. We're just putting it on the graph, and so it ends up making this curve here. Now, this curve can continue. It can continue in this direction. I went down a little too far, but it can continue in this direction. So that's why we call it a periodic function, because that shape of that curve just keeps going and keeps repeating itself over and over and over again. So the domain for our cosine curve, it would be x is an element of the reals, because it does keep going. They didn't give us any restrictions. We, however, are looking at 0 to 2 pi. We just graphed one cycle of it, as they call it. High, 0, low, 0, high. That's one cycle. So that would have been 0 to 2 pi. Our range is -1 to 1. And then this graph started at 1, which was our high value. Started at 1. So that is our parent function for cosine. That is your basic cosine curve. Now let's take a look at our sine curve. So again, over here on the side, I'm going to draw my beautiful unit circle. Sine, this time, is the y portion of your graph. I'm going to put my labels over here. So this is pi over 2, pi, 3 pi over 2, and 2 pi. Those are our key points. I'm going to label my y-axis 1, 2, and then -1, -2. So we'll start at 0 on my unit circle over here. 0, sine value is 0. Sine value up at 90 is 1. 180 is at 0. 270 is -1. And then 360 is back to 0. So again, there's our cosine curve. If I could cut this part and flip it over here, take this part, that's not what I wanted to do. This part, put it over here. Again, there is your unit circle. So it's just cutting the unit circle and putting it on a graph so that we can see it as a graph. Again, this would keep going, so you could have it continue on that way. It can continue on in that direction. Because it is that periodic function, it is going to keep going. So the pattern for sine curve is it starts at 0, and then it goes high, 0, low, 0. So your cosine starts high, sine starts at 0. So that's going to be the difference between those two. Cosine starts high, sine starts at 0. So again, you want to memorize this pattern there. 0, high, 0, low, 0. So for sine, domain would be XER, but again, for this one, we are looking at 0 to 2 pi. Range is the same as our cosine graph. And and this one starts at 0. So it has the same shape as your cosine, it's just it starts at 0 as opposed to starting high like your cosine does. So now tangent is a little bit different than those two because tangent has some asymptotes to it. So again, I'm going to put pi over 2 pi, 3 pi over 2, 2 pi. Label my y-axis. You always want to spread your graph out as much as you possibly can because then it just makes it easier to see and it's going to make things a little bit more accurate. You're less likely to make mistakes. So for this one, if you remember our chart that we did last time, 90 and 270, those have asymptotes to them. Those were undefined values. Tangent of 90 is undefined. Tangent of 270 is undefined. Because if you remember, tangent was y over x, so that would put it as 1 over 0. We can't divide by 0, so those are undefined. The other values we do know is that is 0, that is 0, and that is 0. So again, we kind of get stuck at this point in time because we don't really know too much else. So as I was mentioning, the 45s become helpful for this. So tangent of 45 would be positive. Tangent of 135 being in quadrant 2 is -1. Quadrant 3, tangent is positive. This one's quadrant 4, tangent is negative. So then it kind of helps you see your curves a little bit more. So there is our tangent graph. 2 asymptotes. 45s are helpful for that one to help you figure out the pattern that goes along with it. So our domain for this one is that x cannot be pi over 2 or 3 pi over 2. Your range can be anything, so y is an element of the reals. And then our 2 vertical asymptotes. So you can always check yourself also in your graphing calculator. You can graph these in the graphing calculator. So if you go into your graphing calculator, so as you can see in there, I have sine currently typed in. When you go to graph it, though, you want to hit the zoom button and then number 7 there. You want zoom trig. And then what that does is it turns the x-axis into your key points. This is pi over 2 pi, 3 pi over 2, 2 pi, and so on and so forth. And then negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So it creates that graph for you. Your table, though, you may want to change it so that you're going by 90s. Or if you want to see the 45s, you can change it so that you're going by the 45s. And then you can see the value of your 45s in there also. You don't want to be going up by ones, though. That's not going to be helpful for you. Even if I change this to be tangent, look at my graph because it was already zoom trig. Again, you can see right here, there's nothing there. That's your asymptote. This right here, that's your vertical asymptote. There's your vertical asymptote. So that vertical asymptote keeps getting repeated and it keeps following the same shape there. So calculator, we can check ourselves to make sure we did it correctly. Okay. So we can take these graphs and we can transform them around your coordinate plane. You can move them up, you can move them down, left, right, shrink them, stretch them, whatever you want to do. Excuse me. So this is still very similar. I mean, it's exactly the same as all of our other transformations that we have done. So if you remember this formula here, this is our vertex form of a parabola. I go to this one because you've done so much work with parabolas. A out in front, remember that controls steepness, how wide it is or how narrow it is. The negative in front of there, that is a reflection. H is left, right. K is up, down. So with our sine, cosine, and tangent curves, it is exactly the same thing. They just use different letters for it. So letter A out in front, that's what we call the amplitude of our graph. B is your frequency. How many times does that graph show up in the period of time? C is your phase shift. How is it moving left to right? And then D is our vertical shift, up, down. So it's all the same stuff. Your left-right shift is still in with X. Your up-down shift is at the end. The only additional thing here is that frequency, because we don't have frequencies with the other ones. They're not periodic functions. They don't keep repeating themselves. So here, I have the graph of f of x equals cosine x is graphed over the interval of negative 2 pi to positive 2 pi. So looking at that curve there, because this is just the normal cosine graph, that tells me that this is 1, 2, 3, 4. This would be negative 1, negative 2, negative 3, negative 4. I got my key points listed along my x-axis. So what they want me to do is they want me to now graph this one, j of x equals 3 cosine of x. So the thing that has changed this time is this value out in front, which we would call our amplitude. So our amplitude this time is a 3. So that means the high and the low are still going to be highs and lows, but instead of going to 1, they're going to go to 3. So this one's going to go 3, 0, negative 3, 0, 3. And then it would repeat itself over here. So then if I draw those, it's still the same shape. It's just it's going higher and lower than my first one, f of x, was going. So that is my j of x there. I'll label it j of x for us. So amplitude changes how high up or down it goes. So my last example here, my k of x, my amplitude is a 1/2. So that means instead of going up to 1, it's only going to go up to half. And instead of going down to negative 1, it's only going to go to negative 1/2. So this would be 1/2, 0, negative 1/2, 0, 1/2. And then we repeat over here on the other side. So this makes it a little bit of a shorter graph. Probably could have used my pen, but oh well. There's our k of x. So amplitude changes how high or how low the graph goes. So to determine the amplitude, if you're looking at the equation, it's the number in front of the function. If you're looking at the graph, you would figure out your amplitude by doing your max minus your min and dividing it by 2. That is how you would find your amplitude. And then amplitude defines our range, negative amplitude to positive a. So if I'm looking at my orange graph up here, my j of x, because my amplitude was 3, my range would be negative 3 to positive 3. My k of x graph here, that range would be negative 1/2 to positive 1/2. So whatever that amplitude is, that's negative amplitude to positive amplitude. And now whenever they are asking you about amplitude, you're always going to use the absolute value of it. That's your distance. And again, we'll talk about that a little bit more, but amplitude is always the absolute value of that, because sometimes it will be negative, which just means you have a reflection in there. So down here, they want us to, using the equation, find the amplitude and the range. Amplitude is 3. It's that number out in front. That means our range is -3 to +3. It's negative amplitude to positive amplitude. So for our second one there, amplitude is 1/2. A lot of people want to tell me it's -1/2 because you do have that negative sign there. That's not the amplitude. That negative means we have a reflection over the x-axis. It's not actually our amplitude. Our amplitude is 1/2 here. So then the range is -1/2 to +1/2. Your amplitude, whenever they're asking you what it is always a positive value. So let's take a look at our back here, last page. So we got f of x is 2 cosine of x, g of x is -2 cosine of x. Find amplitude and range, and what is the difference between the two graphs. So for f of x, our amplitude is 2, our range is -2 to +2. G of x, our amplitude is also 2, and our range is also -2 to +2. The only difference is, again, that negative out in front here. That guy right there. And as I kept saying on the front, the difference is g of x is reflected over the x-axis. Negative out in front, just like any other function, means it's reflected over the x-axis. So this cosine graph here, f of x, this would go high, 0, low, 0, high. Because this one is reflected, this would start low, 0, high, 0, low. So it would just be the opposite of the other one. Okay. Number 4. We're going to do f of x equals sine x, k of x equals -3 sine x over the domain of -2 pi to +2 pi. If you are having trouble, you can always build a table. You can use your calculator, help you get a table of values. For our sine curves, the pattern is 0, high, 0, low, 0. That is the pattern that it always follows. So for f of x equals sine x, that's just our parent function. So that's going to go up to 1, down to -1. We're going to start 0, 1, 0, -1, 0. This one will be in opposite, so make our curve. There's f of x. So then for our other one, oh, my negative kind of joined forces there with my equal sign. So because this one is negative, the pattern is going to flip. It's still going to start at 0, but it's going to go low first, 0, high, 0. Because the negative makes everything reflect. The other thing also is we have an amplitude of 3. So 0 down to 3, 0 up to 3, 0, and then the pattern continues on the other side. And there we go. There's our k of x. So memorize the patterns, which one goes in which way, and that's what's going to help you be successful with this one.